Today it's joint work together with my colleague Franz Sinabell, and we're gonna talk about digitalization in livestock farming. It's a study of productivity and productivity growth factors in the end. But as I already mentioned, we are not far at the moment. So I would suggest let's jump right into it. Franz, you're gonna start, right?
Yeah, thank you, Agnes, for introducing this project. It is funded by ÖNB, and we are very happy that we get support for this kind of projects to study a sector that is very small in the economy, but I think nevertheless very important because it's providing the food we enjoy right now, many of us. I'm going to give an outline of the presentation, which is relatively straightforward. So I'm planning to share the context with you, and then go into data that we are using. And when it comes to the difficult part, I'm handing over to Agnes. And we finish with the next steps and the outlook. The context of the study is very simple. We talk about digitalization in agriculture, and here I present a framework and some applications. Because digitalization is very hard to identify and to point down, because is it already digitalization if the diesel engine of your tractor is monitored electronically, or is digitalization what we see here, the cockpit of a tractor with 3 screens, and these are only the visible screens.
It's frozen.
Oh. Sorry for that glitch. Sorry. Yeah, thank you for pointing out that the picture I planned to show you was not on the screen. What you see here is a cockpit of a modern tractor with 3 digital screens and the operator, and you also see some equipment to collect information that is in the ambient spectrum to guide tractors at a centimeter scale across the land. And what we see here is a half-automatic situation where the operator is still in charge with pushing the most important keys so that the tractor and the equipment which is attached to the tractor are operating in the way they should. And many of the processes that are going on are already automatic, meaning that the operator does not need to handle all the control activities that would be needed in case this equipment was not there. From a conceptual point of view, we are at this stage here, where we use diagnostic tools and georeferencing technologies that help to operate these machines in the environment in a better way than human beings could do. And the next stage is that these tools are integrated in applicative tools, which is more or less already at the verge of this. And the final stage will be fully optimized equipment, which is integrated in networks where various machines communicate with each other, and therefore make it possible that platform and network effects can also be utilized, which is not the case yet here. What is summarized here is what I just tried to explain to you. Currently, digitalization in agriculture is at this stage, and what we know is that the farm sector is very heterogeneous, and only a few firms are currently using this kind of equipment and tools. And in Austria, we are not yet there that we have fully automatic machines that are operating at a large scale. There are some, of course, some experimental trials who identify which technologies are likely to prevail, but they are not yet at a large scale adopted in Austria. The literature we have reviewed is very specific, I would say. We have many publications that look at digitalization in agriculture at a very conceptual manner, trying to make conclusions on the sector, giving the experience of digitalization in other industries, and pointing out the specific handicaps that are there in Europe and in Austria as well. It's that farms are very small, that this equipment is very expensive, that we have many people living around, which makes it very troublesome to employ autonomous machines at a large scale. Of course, there are many publications that deal with specific tools, with specific equipments. For instance, automatic milking systems that have been developed 20 years ago and are now standard production technology in modern farms. And we have a few studies that employ surveys in order to find out at what level different farms are regarding digitalization. So there are, in Austria at least, two surveys already where the affinity of farm managers to digitalization is measured. And it's very interesting. In the US, there is a panel survey that was established 20 years ago to measure the level of digitalization in the US, and nothing similar is known to me in Europe, which is a pity because we have policies in place that try to promote digital technologies. This leads us to the research question. Printed here at the bottom. Are there measurable economic benefits? And how does the performance of digitized farms compare with others? This is the focus of the work we are presenting today. And the study we are carrying out is in the context of several studies that have already been carried out in Austria, where productivity and efficiency analysis for the agricultural sector were done. The first one was done in 2006, and this study already shows where the journey is going. All these studies use a specific data set that we also are employing. It's a panel data set that has been established in the 1950 years and has become available for research in 2005. And since then, various studies have been carried out. And you see here the topics of the papers, starting from organic farming, the role of part-time farming, specific sectors like dairy farming, crop farming, and some farm efficiency analysis using the whole farm. The data we use for the analysis in more detail is provided by LBG Österreich GmbH. It's an accountancy company. This company provides bookkeeping services for 2,000 farmers. We have access to a sample of this. We use annual unbalanced panel data, and the primary purpose of this panel is to provide information for the income report that is delivered to the parliament every year. So the purpose of the panel is not efficiency and productivity analysis, but the purpose is bookkeeping and information on incomes. The sample can be segregated to various clusters according to the prevailing technology of the farms. And our case study deals with pork, which is pork pig farming. For this analysis, well, I now hand over to Agnes. We use a subsample of the whole sample.
Thank you very much. So the sample, which is based on those accounting data, reduces to between 500 and 600 farms we observe every year. Our observation period ranges between 2013 and 2022, so we have a 10-year observation period in total. As Franz already mentioned, our panel is highly unbalanced, and our preferred measure of digitalization is a variable or an accounting figure which says IT and office machines software, but I will come to that later, and also what limitations are in place. So let me tell you shortly how we're gonna do our productivity analysis or estimation. So we start with a very usual called Douglas function, production function. So all lowercase letters here indicate that we are using natural logarithm, such that the coefficients, the beta coefficients we're going to estimate are interpreted as elasticities, as vector elasticities. So it's a farm level analysis, and of course the parameter we are mostly interested in is this omega IT. It's the unobserved productivity of a farmer, which is farm and time specific, but known to the farmer, but not to the analyst. And we have our independent, identically distributed error terms, such as always. We're going to use a semi-parametric approach, a so-called proxy variable approach. We follow Levinson and Catrin and Woolbridge as a robustness check. So I'm not gonna go into detail for these estimation techniques, as most of you will know them. But of course, we can talk about them later on, about their advantages or disadvantages. So,
Can you elaborate about the components in the production function?
Yes, I'm going to do that now. So how is our production function specified? Well, on the left-hand side, we're going to estimate not the value added, but the gross output production function. So the gross output consists of the sales of pigs, or the sales of pigs in total, and those pigs are sows, boars, piglets, young pigs, and fattening pigs. So the last one is Mastschweine in Deutsch. And besides of the sales, we add the own consumption and the internal consumption. These are also two posts at the accounting table. So thus consists our gross output, okay? The Y on the left-hand side of the production function. Okay, what's gonna be on the right-hand side? So we have, of course, capital formation. We used here the fixed assets, namely machinery and buildings, as well as, and there is a bit of a question mark, I tried both, as well as the stock of pigs at the end of a year. Why? Because one could argue that at least the stock of boars and sows, so of Eber and Sauen, is not for purchasing, but it's kind of a production input, you know, like a machine which is producing small pigs, right? But this is really something I would love to discuss it with you in the end. Our labor input consists of full-time equivalents of paid and unpaid workers. So the unpaid workers are the family members normally, because in Austria we have a lot of very small farmers. And those are weighted according to the quality of the workforce, as we use the, how is it called? Lohnansatz in German. And this approach, this accounting approach, is used to consider the quality of the workforce, if it's just some kind of helping worker, or if it's a high qualified agricultural worker. So it would deflate the low quality workers a bit. Then we have the self-cultivated agricultural area in hectare, which is also part of the production function, and the intermediates. And the intermediates consists of the energy used, so it's gas, gasoline, and stuff like that. But also the concentrated feed is included in the materials, because I need to feed my pigs, of course, as well as the animal husbandry expenses, which is also another post at the accounting table, the veterinarian costs, as well as the slaughter fee and auxiliary materials. And then one could also include the maintenance costs of buildings and machinery. However, there is a question, as we do also have a lot of mixed farms in Austria. So farms which do some crop farming as well as animal farming. There is the big question what to use for this specific kind of production function of pigs. Okay, so is this the answer of your question, Thomas? According to what kind of...
I'm asking myself, how did you integrate the unpaid labor from your system of accounts?
How do I integrate?
Yeah, there is no wage that you pay for unpaid labor.
Yeah, you could also implement it with wages. I did that as well. The effect was not really significant. To introduce the full-time equivalent in the estimation of the production function is rather common. So I'm not really sure if I understand your question correctly.
Well, if you have a single farmer, for example, without any employees,
Yes,
you
then
have
it's
no
what?
wage costs.
And what?
Then you have no wages.
Yes, we have, because those wages are estimated wages, which are provided. Yeah, which are provided by the accounting company. So these are actually data we do have. But I would prefer to use the full-time equivalents because I do not trust those estimated wages, really. But I try to use them as well, so the effect is not overwhelming. But yes.
We know how many paid and unpaid labor hours are used to produce the output.
Well, not hours, but full-time equivalents,
full-time
something like
equivalent.
full-time equivalent. So, of course, if you have a farm where we have one farmer, but the farmer is not specifically educated for farming, for any agricultural process, we would, for example, have a rate of 0.75 of full-time equivalents. No? Okay. Good. So just that you get an impression, what's the outcome of this? This is the result of the Levinson-Perrin estimator. You have on the left side the density of the TFP, and on the right side you have the density function of TFP growth. As you can see, we have a lot of farms with 0 or close to 0 TFPs. And well, this is just that you get an impression what it is, because I will come to the limitations of our estimation in a minute. So in the next step, as Franz already mentioned, we want to see how the ICT usage is somehow affecting the productivity and productivity growth rates, in particular of those farms. And what we do have from the accounting table are ICT investments. However, we have a big issue there because the LBG company, they switched the program, and as a result, the investments in ICT and office machines were generally transferred to the general account of investments in machines. And this happened in 2018. So from 2018 onwards, we cannot divide between the general investments in machines and ICT investments. So what we try to do now is to work with what we have. And one approach would be to determine those farmers who were already in the sample before 2018, because then we can observe the level of ICT investments. And then we identify those who have invested in ICT, and to drop all farmers which entered the sample after 2018. Because we just don't know if they start to invest in ICT as well. The disadvantage is also just reducing the sample to those who were available before 2018 doesn't tell us anything if there are switches, right, after 2018. So But anyway, this is our suggestion how to cope with this issue. And in the first step, we want to identify a binary identifier, just if a farm has invested in ICT or not. And in the second step, we want to try to account for frequency investments and also for the level of investment. So if it's a high or a high frequent investor, at least before 2018, or if he has invested just once upon a time.
So that was my question. So with account frequency, you mean how it's on an annual basis, right?
Yes. Yes. Yeah, it's annual
more
data.
Than 1, 2 years, 3 years investment.
Yeah, okay. It's annual data.
So Agnes, those that have not invested before 2018 would be firms that never invest.
Yes,
right?
That would be the assumption, because we just don't know. I mean, of course, I would also just split the sample and just use the data between 2013 and 2018 and see if there is a big difference in the outcome. However, we lose half of the sample, right? And we already have not that many farms in the sample. But this is just one of the problems we have with our approach, to be honest. First impression, a simple OLS regression. On the left-hand side, you see the TFP, and at the bottom, the TFP growth rates. And on the right-hand side, you have size categories. So the lowest farms, the lowest 25% of farms, this is the base, and the size 2 is the second highest quartile, and so on. It's a dummy. These are dummy variables, but they identify the second, the third, and the fourth quantile according to the size of the farms. Then we have an identifier.
The size is the number of hectares, or what is the size?
No, it's not. The size here is according to the sales. The revenue. Thanks, that was very important. Because hectare is not, I mean, land is not, at least in my imagination, land is not the main driver in the pig's production, right? So you think it is?
You need land for the droppings. I think there is a mandatory relation between the land that you have to have in order to have a certain number of pigs.
Yeah, you can trade the slurry with a partner who has land. Yeah, so land is important, but it's, I agree with Agnes, it's better to differentiate along the sales. Another way could be to look at the capacity of slots where pigs are produced. But I wouldn't take land.
It sales overall of the farm or sales, pig sales?
Pig sales. It's according to our Y variable of the production function.
The mixed farm, and it's the size of the pig farming business.
Yeah. Because it's also only the TFP based on the pig production and not on the total production. So we do not mix outcomes here. We just have the sales of pigs on the left-hand side.
With mixed farms, for example, there's the land.
Yeah.
That could be quite distorting then.
Yeah. This is also a problem that we, at least not yet, we cannot yet identify the mixed farms, because probably they are the source of some of our problems. We also have included an organic identifier. So if farm is an organic farm, and the identifier if the farm has ever invested in ICT before 2018. Yeah, so it's a binary here, the ICT variable. And what you can see nothing is significant except size 4, except this dummy variable. Yeah. So, but otherwise, the coefficient doesn't look too plausible. As you can see, that the coefficients are growing the larger a farm is, which is somehow intuitive, that larger farms are more productive than smaller farms. We have a negative coefficient for being an organic farm, which is in line with some studies, some previous studies, so that being organic, an organic producer is not always related, or not at all related to being the most productive producer. And we have a positive coefficient for the ICT variable, for the binary indicator for ICT investments. But as I said, nothing is really highly significant. And for the TFP growth, it's only the variable, I forgot to mark it, but it's only the organic, being an organic farm, which is considered to be a positive driver of productivity growth here. But it's also not very, it's just weak significant. Well, our p-value is at 0.09, so yeah. Okay. Yeah.
Did you try interactions with size and ICT?
Not yet. That's a very good point. Not yet. This was, to be honest, just to get the first impression what's going on here, because we are not really further in our analysis, because we have big problem. At least I think it might be a problem. But please disagree with me if you see it anything else, because our results in the production function estimation are a bit puzzling. At least for me as an industrial economist, they are puzzling, because the elasticity, the factor elasticities are partly larger than 1 and smaller than 0. So in the literature, actually, in the agricultural literature, I find some other published results which are similar, which also have factor elasticity that are larger than 1 and smaller than 0. However, I think they are at least surprising. And especially the labor elasticity in the production function. And it doesn't matter if I use Levinson, Petrin, or Baldrige, or Ollie Pigs. I also tried it with Ollie Pigs. The labor elasticity is larger than 1 in almost all of my regressions. And the capital elasticity is mostly smaller than 0, so it's negative. Meaning that buying a new machine is correlated with a negative gross output, which is puzzling in my eyes. Yeah. So therefore, we are still at the question how to specify the production function correctly, and therefore also mentioned what kind of alternative definitions of capital stock and so on we could use, because maybe the origin of the problem is somewhere here in the specification of the production function and the input factors that I used based on the accounting tables.
You consider what role the subsidies play in your subsidies enter your data in effect TFPs? I mean, provocatively saying, buying a machine to get subsidies, living from the subsidies, not working more. Just
yeah. Yeah, that's a very good point. I think we have a variable calling, how is it called? Öffentliche Gelder or something like that.
Subsidies.
So we cannot identify the exact program, the funding program, from where this money comes from, but yeah. But what to do with it? I mean, how to integrate it in a production function? What is it? What kind of factor is it? And to drop those is nearly impossible because every farm in Austria is subsidized. So I would end up with a zero sample.
Capital, sorry.
Okay.
Just small, I think you mentioned already, but the capital stock is measured at the end of the previous year. And then,
Yes.
yeah.
It's always at the
Reverse
end
itself,
of the
it
year.
cannot be an
Yeah.
effect.
No, it's a 31 of December. The stock.
I'm a bit puzzled by a production function. So as far as I remember, most of the estimates of production function at the micro level use a nested specification in which you have the intermediaries which come in as a Leontief envelope function, and then you have Cobb-Douglas between capital and labor as a nested part. Yeah.
Yeah. If you have
So if you look
it on the left-hand side.
Yeah, if you use the same technology that you used in Stata implemented, if you use these estimates by Bakes and Bazoo and so on, that's the functional form that they use.
No, no, you can use a cross output function as well. And I think in all papers, at least Levens and Petrin modeled explicitly the gross value, the gross output function as well with their intermediates. And I think Oli Pakes as well in the paper. But you can do that. It's also so that is not the problem. It is even in the starter code that I use in the help file explains how you have to use it if you do not use value added on the left-hand side, but gross output.
Yeah, but you still have about 3 different types of estimates for in the same starter package, I think. So have you tried all of them, or all of them return elasticities which are implausible, or
What do you mean? I tried all the Pakes, I tried Levinson Petrin, I tried Woolridge, and I tried also the Akerlof correction when I used the value added, which I calculated as my sales minus the intermediates.
nothing works?
No.
What type of measure do you take for capital?
I use the Anlagevermögen of Gebäude and machines. So it's just the asset stock at the end of the year of
On the balance
buildings,
sheet.
machines.
So if you have a firm which has already finished the depreciation cycle, but still has and it has 0 assets,
Yeah,
but still produces pigs,
yeah.
it should
Could
be
be.
hyper efficient.
But it's not the case that the capital stock is 0. Actually, also if I just include only the assets of machines and buildings.
Maybe you could have a look at the output capital ratio.
Mm-hmm.
If the variation there is very, very big, you might have a problem with depreciations.
Yeah, yeah. Okay. I mean, what could also be the source of some problems is that I deflated all those asset values in euros using the GDP deflator, the yearly GDP deflator, and I deflated the sales of the pigs by using a price index. It's a Laspierre index calculated on the prices.
But if production functions don't work, I mean, the simple approach would be just take the average labor productivity.
Yeah.
How does that work?
Haven't tried it yet. I mean, the labor productivity, you have one problem, and I think that is also the case why the elasticity of labor is so high, because you have rather low full-time equivalents there. You have some large firms which has I don't know, 8 full-time equivalents, but most of them are very small. They range between 0.5 and 1.5, something like that, because those are the family farms.
I'd like to come back to the context. Right at the moment, we have a new phase of agricultural policy, and 1.7 billion euros are spent per year to attain the objectives of this program. And this comes to the question or remark of Michael: what role are subsidies playing there? There are subsidies that are in place to boost digitalization. And what we learn from our work is how projects and how data must be shaped in order to have some chance to evaluate these interventions. And the second aspect is that many subsidies are given to farmers to attain objectives that are not directly linked to efficiency. In some cases, it is animal welfare that is not paying higher prices in the output. And this is one deficit that has already been known. So the new program accounts for that and links specific investment with specific labor programs. So in future, we might be able to identify those who participate in an animal welfare friendly production system compared to the others. This is not possible with that data set. And another objective of the program is to improve the quality of farm workers, which explains in other studies why the investment support given to farmers doesn't seem to be efficiency and productivity enhancing. So this is a finding we are aware of. We tried to do it with ICT, and you see the troubles we are running in.
Okay. Thank you very much. This was it from our side, and thanks for all.